Hey guys, Mr. Fourth Dimension. Welcome back to another episode of the Push Reset. So last thing I did was I got well, last thing I did, not in the last episode. What I've done since the last episode, I should say, is I got the electricity stuff working. Right. So I'm just gonna give a quick. Oh, there's a few other small changes. So the anything pushable now has little black squares around it, so it's just sort of a symbolic notation. This thing can be pushed and it'll act in a certain way. And these blue things here are wires. The orange one over here is a generator. It's spitting out electrons into the wires, and the pushable wire can be attached and electricity flows in. So that's all done and working. I could go over how I did it, but I think that that's going to be not too interesting, besides the figuring out how it works in-game is probably a lot more fun. So that's actually one thing I might not spoil at all, right? So let's, instead of doing that, ooh, that's hard. Ooh, that's cool. You see that, what you can do there? That's important. This is an important discovery. I can't move to the right, because that'll kill me. Sorry, I'm getting distracted by potential for, oops. by a potential for a puzzle here. So let me push this up one. If I'm trying to move this across this situation, I can't push it right, because if I go right now I'm gonna die. It's much easier to just push up on it until you get it to here. Very cool. Same concept going this way, I'm sure. Perfect. Okay, so anyway, I'm not going to go over this electricity stuff in too much detail, but there are a few things I need to do. So, one thing that has to happen is when you're sitting next to a hot piece of wire. So, like, this is cold. Right now, this is cooling, is what it's called, but it's not hot. And this is cold, but that's hot, and that should get me. The generator is hot, it should get me. And there's also an alternator that's hot, and it should get me. So we're going to make sure that all of those can be done. So all that really entails is after all movement has been done, after all collisions have been resolved, then you have a late state update. And this is where we look at things that need to update because they're adjacent to wires. So that early state update thing up here, this is where the electricity stuff actually is being done. So now we're going to do the same thing for late state update down here. And the idea is simply going across all of the entities. And what is the term? Entity count, I thought so. Across all entities. Whoops. Basically, if I'm a player, I want to say, you know, we don't even need to do this for loop yet. Like, technically we'll want this soon, but right now all we're really talking about is just grabbing the player entity like so. Entities. Where is it? Entities. Player's always at position 1, so that's his ID, 1. Grab that entity, and then we want to, so one thing we need is a local const, which is just static const, just defined for static const. So we want a local const of positions called relative, this is von Neumann, is the rule here. Oh, how do you spell this? Okay, von Neumann, I think. Maybe it's this way. Not sure. I'm gonna go with that, and I'm gonna look it up. You should look it up too, because that is not necessarily correct. Then what I do here is I just define all of the relative positions that need to be checked in a von Neumann neighborhood, excluding the center cell. Von Neumann, by the way, means that you go up, down, left, and right, but not to the diagonals. In another spot, I have a more MO should actually be using this. That's a more neighborhood. So I'm going to call this the, well, this was what? Relative von Neumann. Okay, so the other one, relative positions, is going to be called relative more, because eventually I'm going to want to move those out. Whoops, got that wrong. Replacing relative positions with relative more. There we go. Okay, so the more neighborhood includes corners, basically. Okay, so then what I do is I take my von Neumann neighborhood and I say I want to loop across it. J is less than the array count of the relative von Neumann positions. And then at each position I want to say if cell is hot. I have this function that figures out if a particular cell contains any hot objects, which hot objects just mean things that are, you know, dangerous and that conduct electricity right now, or that have active electricity in them in the game. Because some things when they get touched by active electricity respond. And one of the things that responds is the player gets burned. So let's add this. So the cell, if the cell is hot, then, oh, no, before we can finish this, we need to get the correct position. So this is the entity's position plus the relative von Neumann position. And what the cell is hot function is set up to do now is when I give it a position, it asks for the cell, and then if there's no cell there, it'll return 0. So this is like, I don't even have to do the if, because the if is encoded inside this wrapper function. Same thing with contains ice. I have a position version now that just does the gets the cell and then sees if that cell even exists. Okay, so back to the cell is hot. Whoops. There we go. Then 32, shock equals 0, shock equals 1, break. Okay, so then what you want to do is say, if shock then we're going to free this entity, get grid cell, grid cell, cell equals get grid cell, right? Okay, and that's what we want, the player's position. We want to get the cell that he is in, and we want to remove him from that cell. Maybe removing from the cell is something that should automatically happen as a part of the freeing routine. And then these would be just 1, technically. Well, I'm going to just go ahead and say, because I know that soon the ID is going to be parameterized. So instead of hard-coding those 1s in, I'm going to do that. And that just says there, delete him now. Now, the other thing to think about... No, this is fine. Up here we have to first compute and then do this because we're going to be removing multiple things from a cell at once. And if we're going to loop over the cell and remove things from the cell, it's better that we first mark who to kill and then kill them. I was thinking down here we need to do the same thing, but we don't because we're not looping over the instances inside of a cell. We're just looping over all the instances. And the remove cell thing will work in that situation. Because we're not asking, like, get the next entity inside this cell ever. We're never asking for the next thing inside of a cell. At least not in a loop that this is contained in, if that makes sense. But let's see how badly I screwed up. Okay, commas. Cool. Now, if that's working, then I shouldn't be able to touch anything that's hot without dying. There we go. There we go. There we go. Alright, one thing I want to do that's not in here right now is I want to add wire block. There it is. I'm going to add an alternator, so what that means is I set him to bright. Oops, I put it in the same location. That's not good. Put it at 9, 9. That's actually going to be interesting. So that's going to start blinking him, so I'm going to have to wait until, there we go, to separate them. So this is an alternator, and when it's bright, it's deadly, and when it's dark, it's safe, right? And you can, if you played the game, you know you can push them along as long as you're synced up with it correctly. There's some other cool stuff you can do. If I push it against that generator, it'll get stuck. And something like this, it can't possibly... Got myself killed. Let's oh, that's bad. That's interesting. What happened? Let's debug that. So a pushable wire isn't a very complicated concept. That's why I wouldn't go into, but I'll go into that a little bit. It's just a separate entity type. Wires are an entity type, and then a wire block is a entity type. And all I have to do to make that work is say, in this loop here, where we're applying rules, if it's a block or a wire block, then apply this rule. Now, the thing I'm asking up here is there a better way for us to start pairing the type of entity with its response to absorbing a push? Because if we're going to end up having just all these else ifs, that's not going to be so fun. So I'm thinking maybe having rules that are given a certain number. So this is like the push block rule, and this is the cloning rule. And then what would happen is entities would have an integer that says which rule they're going to use, and you would just use that as your switch rather than having some weird complicated logic of which entity type am I. Then again, maybe I want the flexibility to say something's rule can change based on which type it is. So it's a little hard to say for sure that I would want that, but it's a thought that maybe just pairing them by type isn't what I want. At least not that way. Okay. So what I want to do now is repeat that experiment that caused a crash. Means first I gotta time this out. That's good. And I want to time this out, and if I push this along here, do I get anything crazy? No. If I just move along, there we go. Grid cell remove. Oh, you know what this is? I know what this is. This is because I'm hard coding more stuff about the player, which only is going to work if the player is actually still alive. You know, in the final game, this never really becomes a problem because when the player dies, things don't continue. But, or at least in the previous game, I don't know if that's still true. Maybe when you die, you can just watch time tick without you. And then you can reset to come back to life. But basically, the trick here is just saying, once you have that entity, make sure that his type is not an error type. As again, there's still gaps in the list of all entities where there aren't by gaps I mean spots where the entity isn't really supposed to be an entity in action right now. So one thought I've had, and I'll explain why I've had this later, but one thought I've had is that maybe I want a sort of a concept of a list of entities, a way of listing entities so that I can list which ones are there you go, now things are just ticking on their own. So I can have a way of listing which things are in certain conditions. So if something can be moving, then it should be in one list. If something is conductive of electricity, then it should be in a list. If something needs to move on its own, like if it's a bug or the player, anything that has a non-stationary default rule maybe wants its own. Well, the reason you wouldn't want that is because push blocks, you want to do that all in one step. So anything that can move, basically, push blocks, the player, anything that can move, bullets, and bugs should all be in this list of things that can possibly move. Right, and the reason you would want that is because you have a lot of circumstances where you're looping over everybody and you're only updating some subsystems. So like the electronic system right now touches every entity and updates their state, but the only things that ever change state, or that even play in the system, are wires and pushable wires. Right? Other things might ask, like the player might ask, is there a hot thing next to me? But he doesn't need to update his electricity state to do that. So that means that there's only, out of all the entities here, which is all of the walls around surrounding the edge, 4 push blocks, a clone, and a pit, and a bunch of ice there and there. The only ones that are actually needing to update their electricity are 2 push blocks here and here, 1, 2, 3, 4, 5, 6, 7 wires, and a generator. So I'm talking about like 10 entities out of almost 100. And yeah, 100 seems like a lot, but there's a lot of entities around the wall there. That can't be 100, can it? At one point I was playing and I saw that I had like 80 entities. That seemed weird to me, and it still seems weird, because if the whole thing is 300, then I would need to be 1/3 full to be at 100, and it doesn't seem 1/3 full to me. Right, maybe I had a lot of clones in existence at that point. Now, that's all fine and good, but there's far more to get done. So, right now, we're just doing this on one entity, and it's the player. And this is the player's particular rule, that if he gets shocked, he wants to die, right? But the real issue is, some things care if they get shocked, other things don't care if they get shocked. So what we're going to add is another type like here, and I think this brings us to 16, called shockable. Shockable just says, I want to receive information about when I get hit by electricity, but I'm not actually conductive necessarily. Or if I am, that's irrelevant, right? My own electricity doesn't... it's orthogonal, I guess. So, the point is, first of all, let me count these up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So we're at 16. If I want to keep it at 16, then I can get rid of 4 by turning this into a bit field, right? Which I don't see myself adding much more than that, like more flags now. But there might be some numbers, like there is an idea of like that pushing, multiple pushes having different priorities. And if I end up with a system like that, I'll need another byte that's a number. There's also the question of, like, does type really need to be a U16? If we don't end up with 255 types, then if we end up with less than or equal to 255 types, then we can just set this to a U8 and that'll save us a byte. But for now I'm going to leave it the way it is, because I'm not actually at the point where it needs to be optimal. I'm just trying to see if I can constrain myself and still do interesting things. But, shockable. Let's go to add player. He needs to be shockable. Okay, and then, when I have ID equals 1, oh, that's it, all just solid equals 1. What I'm looking for is I32 ID equals 1, right? Or I16 ID equals 1. What? Where is this? Entity type does not equal... Yeah, why wasn't it finding that? Oh, I have 2 spaces there. That's weird. Okay. So I want to turn this into a loop. ID is less than entity count. And this, again, a list of shockable things would be nice. Rather than, because if you have a list of shockable things, you don't even really need to know if a particular entity is shockable. The only time you need to know if somebody is shockable is to say, like, this right here, right? The only time we're ever going to probably look at shockable is to ask, is this thing shockable? And if we just had a list of shockable things, we wouldn't need to encode that inside the entities, because their presence in the list would just mean we iterate over that list and everything in there is shockable. But, anyway, the point is, after determining that we do want to try to shock this thing, we go ahead and compute if it should be shocked, and if so, then we will switch on its type. And the only type we have that's getting shocked right now is the player. But what this means is that now it's easy to add other things that can also respond to shocks and in their own way without just getting killed like the player, right? And yeah, so his particular rule is kill me. Let's add the great bullet gun now. Gun or shooter bullet. In the game, they look like discs. If you're wondering what I mean by shooter, and or by bullet, and the shooters are the blocks that are teal, that are cyan or whatever, that shoot these things. I don't know my colors. It's not that I'm colorblind. I'm just color illiterate. So, what we want to make the shooter gun work, yeah, we need a few things, don't we? Might need another Boolean flag already. Which means I'll go past 16 right now because I don't feel like working on compressing that. Okay, so to make a bullet work, it's right here, right? So right now the only guy who has a rule is if I'm not slipping on ice, do this. Well, bullets actually will have their own rule now, which is whichever way they're facing, they always push that direction. Very simple. The way you do that is you say grab the entity and get his facing. Right, there is the direction that an entity is facing currently. It never should be a stop. And then what we want to do is we want to say that we can add bullets. So add wall app vars. There we go. Good way to get up into this region. I'll just grab a copy of one of my other add functions. This will be add bullet, and a bullet needs the correct type. Oops, not what I wanted. There we go. He's got the position. He is not a floor piece. Okay, bullets kill power. They're supposed to kill living things like the player. What's the player's kill power? I think it's a 1. Yeah. But it's also got to kill bugs. And bugs have to kill players, so bugs have to be at least 2. And bullets, bullets I'm going to set at about a 5. I think that's what I used to have them at. I don't think all of the kill powers are used, which seems odd when you think about it, but it doesn't really matter that you make them dense when you're done, right? Doesn't matter. So, I think that's a good kill power for the bullet. And then the bullet also needs a direction upon its birth. That's going to be important for the bullet, because he just moves that way forever. So which way he's facing when he's created matters. What else is there about the bullet? They kill power. They have another property that I'm trying to remember right now. Oh, they're flying. That's what's important about them. They fly. This will be the first flying thing that we've added to the game. Flying is important because it means it doesn't care about ice, which wouldn't matter, but it also doesn't care about pits, which would otherwise kill them, because they have a lower kill power. Right, but the fact that the bullet flies and the pit's on the ground means that the bullet won't fall into the pit, basically. Now what we want to do is we want to say that we're going to add a bullet near the beginning of the, I'll put it, I want to put it in such a position that I can play with it, or make a couple of them then. Okay, so one to his right, or one to the left of him moving right, and one above them moving right. What's wrong? Oh, that's add player still. Bullet. Still something wrong, huh? What? Can I convert argument 2 from initializer list? Okay. They're mad because this isn't a direction, and so it doesn't look like it matches the struct that it's supposed to match. What I probably should do is make a quote-unquote constructor function that will take a U8 so that I don't have to keep on casting the direction. And we'll take the, oh, that's not going to be right. That's got to be entity ID. Or I guess I could just say I. That'll always be the right ID. Now, it's better that I use entity ID, and the reason for that is if I end up changing the fact that it's a non-dense array and that the IDs in the entity can always be correct, but the location in the array might not always be correct. Where are my bullets? I think that they're there, and I'm just not, yeah. So they're there. I can't see them because I haven't drawn them. Okay. Int block colon. There we go. Just grab a copy of anybody, doesn't really matter. And bullet. Draw bullet. Now I'll go up to draw wall. I want a copy of this. Draw bullet. So his width is much smaller. He's going to be 8 by 8. Now the other trick is that he should have some sort of method for identifying his direction, which means something maybe like the player. You know, I've just realized because I'm doing OpenGL, I don't really need to do it this way, but for now I'm going to do it this way. So we're drawing a bullet. The bullet's going to be black. Alright, and now to encode which way the bullet is moving. That's a matter of taking these in M1, M2, right, so those are the things that set. So I just need different M1 and M2 values. So if he's going to be an 8 by 8 little square, then I want it to move out about 2 pixels and spread by about 2 in each direction like that. Whoa. And dir is not right because we're not passing a dir. Direction, dir. Alright, I'm almost out of time for today. Draw a rectangle. That should be saying bullet color. This should be saying bullet color. And these should be saying bullet color. You need the entity's direction. Oh, I'm gonna have to cast that. Which means what I really should do is in the draw function, I should accept the U8 and do the cast in there. There you go, little bullets. They look like little miniature players, but they're gonna kill me. Now the weird thing is, right now they're not gonna move into the wall like this, so they're gonna stop there. Why is that? Because if you think about the movement rule, it says if you run into a solid, stop. So we need things that don't care about that rule, right? And that's why I'm saying we might need a new flag here. Basically, the idea is that a bullet has some sort of property that's like non absorb, or well, what is it doing? It's the solid won't absorb its push. So ignore solid, right? Move even if there's a solid in the way. That will lead to the effect we really want. So when we're adding a bullet, we want to tell it that it should ignore solids. So the next thing I'll probably do is mess with getting that bit field worked out and turning all these booleans into flags, just because I want to, if that's the final system I'm going to have, I don't want to put it off switching to it. So, not a big deal. The big deal is down here, when I'm moving, I want to see resolve all pushes. Yes. It's in here somewhere. So you're going along. So this part here is generating all the pushes, right? And then this is step 2A, generate pushes. Step 2B, resolve all pushes. And when you're resolving a push, the idea is quite simply that if entity ignores solid, so if you are not someone who ignores solids, then do the normal thing. And check for solids. If you do ignore solids, then none of this matters. None of that will happen. Now we should see them run straight into the wall and get destroyed. Yep, cool. So, that's a good bit of progress. Thanks for joining me. If you enjoyed it, make sure you keep your eye out, because there'll be more. See you around.